what we've actually shown is that this is not true. It's actually equal to even. The difference between, oh, we haven't shown that. I'm so sorry, I've misspoken. We've just shown that this is not true. And you know what I'm gonna do? In the second half of this video, I'm gonna show that it's true that it's even, because the reason I say I didn't show that is because I only showed an example. To prove that it's even, we have to say for all AB. So for all integers a and b, if a and b are odd, is the difference between a and b even? So what do we do for a for all proof? Well, actually, again, first let's think of examples, right? We have if a and b are both equal to 1, we have 1 minus 1 is equal to 0. That's going to be even. We have 5 minus 7. Those are two odd numbers. It's going to equal to -2. That's also even. So we've already seen some examples where this is true. So let's try and prove it with the assumption that it's probably a true statement. So how do we prove a for all? Well, we let, and what do we let? We let our p. Our p in this case is this. And we also let any pre like definitions or any variables we define before our p. So let a, b be integers such that a and b are odd. Then let's unpack more clearly what we define a and b to be odd as. Then a is equal to 2m plus 1 and b is equal to 2n plus 1 for some m n that are integers. Fantastic. Okay, where do we go from here? Well, now we can check this and see if a minus b does in fact lead to something looking even. So let's write that down. We say a minus b, we say next, comma, a minus b is equal to 2m plus 1 minus 2n plus 1. Put these in brackets. So what does this mean? Well, when we do this, it becomes -2n, -1. Well, 1 plus -1 is going to be 0, so we end up getting 2m plus 2n, which is going to be equal to 2 multiplied by m plus n, right? We can factor the 2 out. What does this look like? This looks like 2 times some sort of integer, which means that this is in the form of an even integer, so we can then clearly state where m plus, oh, I'm so sorry, this is a negative down here, okay? M minus n is an integer, so a minus b is equal to 2 times m minus n makes a minus b even, so the statement is true. Fantastic. So I've just proven that not only have we proven that the difference between two odd integers is never going to be odd, or sorry, for all odd integers is not odd. And then we were asking ourselves, well, maybe it's even, right? Because the examples we chose to disprove the original statement gave us even numbers. And it turns out that that is true. The difference between all odd integers is always going to be even, which means that not only can we say that there exist odd integers for whose difference is not odd, we can say for all odd integers their difference will never be odd.